All right, so we are continuing with multiplying fractions. Today we're actually going to talk about comparing multiplication and addition, like how you know which is which, whether you're multiplying or whether you're adding. But before we start with that, Mrs. Lopez found this little video on multiplying mixed numbers. So I thought it'd be fun to show you guys. It's a number rock video. So let's watch this.
I made a fence to rehabilitate a giraffe around 1 2/5 acres by 1 1/2. I had to find the area before planting the grass. The first thing I did was I made a graph. I converted each to improper fractions. 7/5 and 3/2 were their equivalents. I multiplied and got 21/10, which equal 2 1/10 acres inside the fence. Convert to improper fractions that are simplified. Numerators and denominators get multiplied. One last step you might need to perform. Make sure the answer is in simplest form. Mixed numbers become improper fractions. Then we do the multiplication. Inside the fence for my Billy Goat herd, the area is 2 1/2 acres by 3 1/3. I converted to improper fractions, like a good shepherd. Their equivalents were 5/2 and 2/3. I multiplied and got 50/6. That's how many acres I planted with my oat seed mix. I simplified the fraction and got 25/3. I ate 1/3 acres. Convert to improper fractions that are simplified. Numerators and denominators get multiplied. One last step you might need to perform. Make sure the answer is in simplest form. Mixed numbers become fractions. Then we do the multiplication. Mixed numbers are made of whole numbers and fractions. To multiply, convert to improper fractions for each transaction. The product of multiplying mixed numbers has a denominator smaller than the number it's under. Improper fractions, so convert it back to a mixed number in its simplest form. And that's that. Mixed numbers become improper fractions. Then we do the multiplication. Visit numberrock.com for ad-free videos, lesson materials.
All right, so just kind of goes through the steps for multiplying mixed numbers, which is what we've been doing. We change them to those improper fractions, and then we multiply, and then we simplify it back to a mixed number. Are there any questions on that? I'm checking in my chat right now. No? All right. So let's go ahead and take a look at where we left off in our math book. We are on lesson 3-7, which is on page 83 in our student activity book. You all should have yours out right along with me right now. Okay. So the first two fraction bars up top show us the difference between what adding fractions looks like on fraction bars and what multiplying fractions looks like on fraction bars. When we add fractions, we just circle the two numbers. So I have 2/5, so I circled 2/5. I have 3/5, so I circled 3/5. And whatever the total number of fifths is that I circled, that's my answer. But multiplying was a little bit different, remember? We had to divide our fraction bar first into one of the numbers, so that was fifths. So they circled their 2/5. But then since we're multiplying, each one of the fifths that we already had, we had to divide into 5 more sections. And I take 3/5 of each of the ones that's inside the 2/5. Whew. Which is pretty much the same as 3 times 2 is 6, 5 times 5 is 25. So let's look at number 1. Number 1 says, which problem above, so the adding or the multiplying, which one has a greater answer?
Adding.
I heard one adding.
Adding because it's one whole.
Yep.
Adding. It's adding.
Okay, you're right, it's adding, because when we added them, we ended up with an answer of 1 whole. 5 over 5 equals 1 whole. 6/25, that's not even a half, right? That's less than a half. So when we add, we come up with a larger answer. Let's look at these down here. Circle the problem that will have the greater answer and then solve. So 2/7 plus 3/7 or 3/7 times 2/7. Which one is going to have a greater answer, adding or multiplying?
Multiplying. Adding. Adding.
Think about how we looked up here. Let's go ahead and solve them. Let's solve another one so we can look at it. Because I think some of you who are saying multiplying, you're forgetting one of the steps in the multiplying. So let's look at the adding one first. We have the same denominators, so that's super simple, right? Because when we add, we have to have common denominators, and then our denominator stays the same. And then we add our numerators. 2 plus 3 is 5. But with multiplying, we multiply our numerators. 3 times 2 is 6. And I think this is where some of you maybe thought, oh, my denominator is 7. It's not. Remember, you have to multiply your denominators also. So 7 times 7 is 49. Now, which one gives us the larger answer, adding or multiplying?
Adding.
Adding, definitely adding gave us a larger answer. Okay, let's look at the next one. 1/6 plus 3/4. Uh-oh, we don't have common denominators. We have to find those common denominators. Can 4 go into 6 evenly?
No.
No. So let's see, if I count by 6s, next comes 12. Can 4 go into 12?
Yes. Yes.
Yes, so 12 is going to be my denominator. You guys remember how to do this?
Yeah.
How do I get from 6 to 12?
You multiply by 2.
Times 2. What's 1 times 2?
2.
2.
2.
How do I get from 4 to 12?
You multiply by 3.
Times 3. What's 3 times 3?
9.
9. Now I can add them, right? Now I have 2 12s. Excuse me. Plus 9 12s. 9 plus 2 is?
11 12.
11. Keep my old denominator, which is 12. That's almost 1 whole, isn't it?
Yep.
But now let's go to multiplying, which is so much easier. Doesn't matter that our denominators are different. Does not matter. Okay. 3 times 1 is?
3.
4 times 6 is?
24.
24. Did we get a larger answer when we multiplied or when we added?
Added.
Added. We have to circle that one.
Easy.
Okay. Good. So when we add and subtract, which one gives us a larger answer?
Adding.
Adding. Yep. Yep. Adding will give us a larger answer. All right. These, I'm going to be honest with you guys, these a lot of times confuse me, but I'm going to do my best, and I hope that you do too. Sometimes I like to just substitute numbers in where they have the letters because I can see it better with numbers. So if that helps you, please feel free to do that. But it says, tell whether the answer will be less than or greater than the red number. Okay, is it going to be less than or greater than the red number? So I'm going to put some numbers in here. I'm going to put, oh, let's say 4 plus 5. We'll say, actually, I want my A to be larger because I want to use the same A and B all the way through. 5 plus 4, we'll say. So is my answer to 5 plus 4 going to be greater than or less than 5?
Greater than.
Greater than, right? When I'm adding two numbers together, when I'm adding just two whole numbers together, my answer is going to be greater than my addend. It's going to be greater. What if, and I'm going to use my same numbers, 5 minus 4. Is my answer going to be greater than or less than 5?
Less than.
Less than. Yeah, so when I'm subtracting, my number's getting smaller. Less than. And how about, oh, let's see, B was a 4, A was a 5. 4 times 5. So how about when I multiply my whole numbers? Is my answer going to be greater than or less than 5?
Greater than.
Yep, greater than. So Those are all pretty logical, right? Those are all pretty easy to think about when we're doing our whole numbers. But now let's think about it when we have fractions. Okay, let's think about it when we have fractions. And I'm going to use, we'll say 3/4 and 1/4, just to make it easy, okay? Just to make it easy. So if I add 3/4 plus 1/4, is my answer going to be greater than or less than 3/4?
Greater.
Greater, yes.
Greater.
Okay, let's think about those same numbers. 3/4 minus 1/4. Is my answer going to be greater than or less than?
Less than.
Less. Look, so far these are both the same. These are both the same, right? Whether it's whole numbers or fractions, doesn't matter. Let's think about multiplying though. 1/4 times 3/4. Well, that gives me what? 3/16? Is 3/16 greater than or less than 3/4?
Less than.
Less than. Uh-oh. These are opposites, aren't they? When we multiply whole numbers or when we multiply fractions. So when we're multiplying fractions, we're getting smaller and smaller pieces. That's the way to think about it. We're getting smaller pieces. So that's why it's getting less, okay? So it's different because and I'm going to write this in, and I would like you to write this in too so you remember this. For fractions, you're taking part of a group yeah, we'll just leave it at that. For fractions, you're taking part of a group. And that is evident up here, right? Because we had our 2/5 and then we took part of that 2/5. We took part of those groups. So when we multiply fractions, we're taking part of a group. Okay, did we get that written in? All right, so, oh, and then somebody left me because I'm making you guys show me your work. Dun, dun, dun. She's such a mean teacher. All right, let's look at the next page, on to page 84. So 84, we're gonna have to start doing some figuring. We're gonna need to decide, are we adding or are we multiplying for our answer? And when we get our answer, we need to make sure that it makes sense, okay? Or we could be subtracting too. So Amber, a very fit snail, moves 7/9 yard in 1 hour. She challenged the other snails to try to do better. If Willie moved 4/5 as far as Amber, you think we're going to multiply, add, subtract? What are we going to do with our 4/5 and our 7/9 to figure out how far Willie went?
Subtract. Divide.
We haven't even done dividing with fractions. We're multiplying them. Yep. Yep. Because he went 4/5 of Amber's distance. 4/5 as far as Amber. So it's not, yeah, so we need to multiply. So 4/5 times 7/9, he went 28/45 yards. How about Dusty went 1/3 yard less than Amber?
That's subtracting.
You are correct. That is subtract. I'm just going to write subtract on here. We're not going to solve it. We're just going to make some notes because it's less than, right? So we need to subtract. He went 1/3 less than Amber. Pearl went twice as far as Amber.
Multiply.
Multiply. What are we going to multiply by? 2 times 7/9, right? Because twice is 2.
Yes.
Could I have also done addition? Could I have done 7/9 plus 7/9? I could, right?
Yes.
7/9 plus 7/9 because that's the same as 2 times 7/9. Okay. Casey moved 4/9 yard more than Amber. What's more than mean?
It's
Add.
Add. But hang on, but Casey went more than Amber. So I'm sorry, so yes, I am gonna add. I'm gonna add 4/9 to 7/9 to figure out how far Casey went. And then Minnie moved half as far as Amber.
Subtraction.
You guys see a pattern here so far? As far as, as far as, as far as. What are we doing for all of the as far as words?
Multiplication.
Multiply. So we're going to multiply. What am I going to multiply for number 15? 7/9, but what am I going to multiply that 7/9 times?
What?
1/2.
1/2, right? Half. 7/9 times 1/2. Okay? Half as far means 1/2. So we're going to multiply by 1/2. So you really want to look for some of those clue words. And hopefully you marked yours like I marked mine in my book, because you are going to have some word problems to do as practice on your own. So that will help you to be able to look back and be like, oh, did I multiply? Did I add? What did I do when it said as far as? Okay. All right, deep breath. Whew. We're moving into the properties. But here is the great part about the properties. They mean the same things. They mean the same things, right? We have associative and we have commutative. Do you guys remember my little trick that I like to do to remember which is which?
Yep.
What is it?
It's A comes first in the alphabet and G comes first in the alphabet. So associative and is grouping, and commutative comes second, and order comes second in the alphabet. So it's commutative with order and associative with group.
Landon, you just got a gold star for the day. Somebody listens to me. I feel good now. And this is just mine. You can remember them however you want. But like I've said, I remember the words grouping, meaning they move the parentheses, and order, meaning they can flip-flop the order. I remember these words better. But these are the words that they always use in math, associative and commutative. So I remembered that A comes before C, just like G comes before O. Okay. So they're showing us a commutative property here. So, and again, here they are with letters. But AB times CD is the same as CD times AB. Okay. And then they went through and they broke it down into steps. So we know that we multiply our numerators, A times C and B times D, which is the same as C times A, right? All we did is we flipped those around, and D times B. All we did was flip those around. The order does not matter. And then on the last one, they just basically flipped this problem around the other way. Okay, so all they're showing us on that commutative property part is that the order doesn't matter. 1/2 times 2/3 is the same as 2/3 times 1/2. Do you guys agree with that?
Yep. Yeah.
Yep, because 1 times 2 is 2. 3 times 2 is 6. 2 times 1 is 2. 3 times 2 is 6. Same thing, doesn't matter which way it goes. 1 times 2 is the same as 2 times 1. 2 times 3 is the same as 3 times 2. Moving on.
Already.
Associative property, that's our grouping property, right? So as long as we have all multiplication throughout, it doesn't matter how it's grouped. So again, I could have 1/2 times 2/3 times 3/4 is the same as 1/2 times 2/3 in parentheses times 3/4. Okay? Because 2 times 3 is 6, 3 times 4 is 12 times 1/2. 1 times 6 is 6, 2 times 12 is 24. Let's see if I get the same thing over here when I do the parentheses first. 1 times 2 is 2, 3 times 2 is 6, times 3/4. 3 times 2 is 6, 6 times 4 is 24. Same answers at the end, right? Since it's multiplication all the way through, it doesn't matter the order that I multiply in. I can multiply in any order. Okay? That is our associative property. Whew. Distributive property. So look at what they have here. They have a number times two things that we're adding together. So they're saying, instead of adding these and then multiplying, I can take my 1/2 and say, okay, what's 1/2 times 2/3? And then add that to 1/2 times 1/4. So they're doing the multiplying and then they have to add them. So it's just breaking up the problem as they solve it. 1/2 times 2/3 plus 1/2 times 1/4. So if I had 3/4, look at, they used a lot of my fractions I like to use. 3/4 times 1/5 plus 2/6. I'm going to take my 3/4, I'm going to distribute it to my 1/5. 3/4 times 1/5. Put my little plus sign in there. And you don't need these parentheses, but I kind of like to have them. And then I'm going to multiply that 3/4 times my 2/6 also. 3/4 times 2/6. And then once I get my multiplying answers, I would add. Okay. Just a review on there. Don't worry too much about those right now. Just looking at how the properties that we use for addition also work for multiplication. All right. We're going to skip this part up here, this mixed practice, because I really want to look at the word problems. And most importantly on the word problems is not solving them right now, but I want to look at, is it addition, subtraction, multiplication? What operation would I use to solve that word problem? So can I have somebody go ahead and read me number 30?
Daniel put some wheat flour into an empty bowl. Then he adds 2/3 cup rye flour to make a total of 2 5/12 cups of flour. How much wheat flour is in the bowl?
Thank you. And so this says write an equation. So remember, we got to write those equations. So I'm going to start with my variable on this. I'm going to write a situation equation. Okay, that should be words familiar to you from 4th grade, a situation equation. So Daniel put some wheat flour into a bowl. We don't know how much flour it is, but he's putting some in there. Then he adds 2/3 cup, whatever he had, plus 2/3 cup, to make a total of 2 5/12. Now this is called a situation equation because this isn't what I'm going to do to solve it, right? What would I do to solve this problem?
Subtract.
Subtract, yep. So to solve it, I would do 2 5/12 minus 2/3. We're not actually going to solve it. We're just going to talk through the equations on these. Okay. Manuela has a bag containing 5 1/3 cups of sugar. She uses 1/8 of the sugar in a recipe. How much sugar does she use? That's kind of a confusing question. I don't like the way that's worded. So 1/8 of the sugar, 1/8 of the bag of sugar, I guess is the words I'm missing. Okay. So what do you think our operation is for this one?
Subtraction.
So she has a bag that contains 5 1/3 cups. She uses 1/8 of the sugar, 1/8 of the 5 1/3 cups. What does of mean?
Multiply.
Oh, I shouldn't hear crickets at that time. Yes, of means multiply, of means multiply, of means multiply, of means multiply, of means multiply. What does of mean?
Multiply.
Multiply.
Woo! Hopefully those of you that are muted also said multiply. Okay. Yes, she uses 1/8 of, which means multiply of the sugar. Ashanti has a bag that contains 4 1/4 cups of rice. She uses 2/3 cup. How much rice is left in the bag? What's our operation?
Multiply.
Is there an of between these? I mean, I see that she has a bag that has 4 1/4 cups of rice. Okay, that's not the same kind of as she's using 1/8 of the sugar. So I do see that confusion. I'm sorry.
Subtract.
But yes, this is subtraction. Her bag has 4 1/4. She uses 2/3 cup. The difference is this one was she uses 1/8 of the sugar, 1/8 of this amount equals R for rice.
Okay.
Seth's route to the school is 1 3/10 miles long. He also walked 4/5 miles, or he has walked 4/5 miles so far. How much farther does he have to go? What's our operation?
Subtract.
You got it, Jackson. 1 3/10 minus 4/5. Okay, 1 3/10 is the total distance. He's walked this far already. How much farther does he have to go? Well, to figure that out, we have to subtract. Mara's walk to school is 1 2/5 miles. She is 5/8 of the way there. What's my operation?
Multiply.
Multiply. So she's 5/8 of the way. It's not saying she went 5/8 miles, like how this one said he went 4/5 miles. This is 5/8 of the way. So 1 2/5 times 5/8. Okay. I know it can be a little tricky, but hopefully you see the difference in those two. This one is telling you exactly how far he went. He went 4/5 mile. This one, it's not saying 5/8 miles, 5/8 of the way. So it's a fraction of the way there. Okay, let's take a look in our homework books. I'm gonna make some changes here, so hopefully you're with me. Okay, for this top part up here, I want you to just do the odds. But keep in mind, you need to look at the symbol because some are multiplying, some are subtracting, some are adding. So if it is adding or subtracting, what do you have to do?
You have to
Pick a common denominator.
You have to find a common denominator. Yes, you cannot add or subtract without finding a common denominator. Okay? For 13 through 17, we're going to do all of them, but pay attention because we're going to go through and read them and figure out right now if they are addition, subtraction, or multiplication. So Rodrigo's fishbowl holds 7/8 gallon of water. It is now half full. How much water is in it? What would I do to solve that problem?
multiplication.
Multiply. Yes, I'm going to multiply on that one. I'm going to put a little X at the end to remind myself to multiply. Kenya jumped 7 1/6 feet. Janet jumped 6 1/3 feet. How much farther did Kenya jump?
Subtraction.
Yes, that is a subtraction problem. I need to subtract those two fractions. A group of hikers walked 8 7/10 miles to Caribou Cave and then 5 1/5 miles to Silver Stream. How far did they walk all together?
Addition.
Addition.
Addition. Yes, all together with our keyword for addition. A recipe calls for 3/4 cups of flour. Esteban wants to make 1/3 of the recipe. How much flour will he need?
Multiplication.
Multiplication.
1/3 of the recipe. A truck was carrying 2 1/8 tons of sand. When it arrived, only 1 1/2 tons of sand were left. How much sand was lost along the way?
Subtraction.
Subtraction, yes, because the sand was lost. Okay, so you're doing all of 13 through 17. And then let's take a look at the back real quick.
Oh, that's easy.
Oh, we'll just say evens on the back.
Yay.
Okay, evens on the back. So I want everybody to stay on. Nobody's logging off right now. You guys are going to stay on and you're going to work with me. I will put you in a breakout room if you want a breakout room, but you need to stay on here and keep working.